So hello everyone, my name is Atharva Suhas Kasture and we will now be talking about transaction management. So these are the concepts which we will be studying. So what is transaction in DBMS? So transactions are a set of operations that are used to perform some logical set of work. So a transaction is made to change the data which is present in the database. So this can be done by inserting a new data, updating the existing data, or deleting the data that is no longer required. So example of transaction is nothing but, for example, sending the money from your bank account to your friend's bank account. So this transaction will have certain steps. So what are these steps? Reading the balance from your account, deducting certain amount, and then again writing the new amount into your balance. Similarly, for your friend's account, certain steps are there. Reading the balance of your friend's account, adding the sum into your friend's account's balance, and then writing the new balance into the friend's account. So these are certain steps. Now, asset properties. Basically, asset properties are used to maintain data integrity, consistency during transactions. So, what is asset properties? So, A stands for atomicity. Here, it means that either the transaction will occur or will not occur at all. C means consistency. So, it means that the transaction uh, is consistent or the database is consistent before and after transaction. Talking about an example of the previous example, the money which is lost from your account and the money which is gained by your friend's account is same or the value is same. So this is nothing but consistency. Isolation means multiple transaction can take place at the same time without interfering with the other transactions. So D means durability. Durability means once the transaction is completed, the changes are permanently stored in database. So these changes are stored permanently with the help of the commit command. Now, state diagram. A state diagram is a visual representation of the different states that a transaction can go through during its execution. So there are number of states that a transaction can go through. So this is how a state diagram looks. So now these states decide the regulations which decide the fate of a transaction, whether it will commit or abort. Commit means just discuss now. The changes are permanently stored in database, and abort means the entire transaction is cancelled. Now, types of states. First is the active state. If a transaction is in execution, then it is said to be an active state. During this state, read or write operation can be performed. Partially committed state. All read and write operations are carried out in the main memory, local memory, or a temporary memory rather than directly on the database. So this mechanism prevents inconsistencies by rolling back any changes made to the database if a failure occurs during execution. Rolling back, in simple words, we can consider it as undo certain operations in a transaction. So types of states means failed state. The next state, a transaction considered failed when any one of the checks fails or if transaction is aborted while it is in the active state. If a transaction is executing and a failure occurs, then the transaction goes into the failed state from the active state. Now committed state. If a transaction completes the execution successfully, then all the changes made in the local memory or temporary memory during partially committed state are permanently stored in the database with the help of the commit command just now discussed earlier. So the next is aborted state. If the transaction fails during its execution, it goes from the failed state to the aborted state. The uncommitted changes are either deleted or rolled back. The transaction at this point can restart and start afresh from the active state. Terminated state. State of transaction reaches terminated state when certain transactions which are leaving the system can't be restarted. Now, what is a DBMS schedule? So a sequence of operations from one transaction to another is referred to as a schedule. It ensures that the order of operations within each individual transaction is maintained. When multiple transactions are executed concurrently, a specific sequence is required for the operations to be carried out properly, as only one operation can be executed on the database at any given time. So here is an example where there are two transactions going on concurrently, and at a given time t1, only one transaction operation is happening. Like at t1, transaction T1 inside read X operation is being performed and no operation is being performed on transaction T2. At time T2, read Y is being performed on transaction T2, but not any operation being performed in transaction T1. So now, what is a serial schedule? In a serial schedule, a transaction is executed completely before starting the execution of another transaction. So here, very Simple example is there that first of all, the transaction A, all steps are completed, and after completion of this transaction, transaction B is starting, as opposed to the previous case which we saw that both are happening concurrently. Now, what is a non-serial schedule? It is opposite of serial schedule. It contains many possible orders in which the system can execute the individual operations of the transaction. So this is an example of non-serial schedule. So what is a strict schedule? In strict schedule, if the write operation of a transaction precedes a conflicting operation, read or write operation of another transaction, then the commit or abort operation of such transaction should also precede the conflicting operation of another transaction. So in simple terms, we will consider an example. Let's consider two transactions T1 and T2. Transaction T1 performs a write operation, say W of A, which is writing to a variable A, and suppose transaction T2 wants to perform a read or write operation on A, but it must wait until T1 commits or aborts. Only after T1 finishes, either T1 will commit, transaction is completed, or abort, means transaction is cancelled. Then only T2 proceed with its read or write operation on A. In this example, T2 is not allowed to access A until T1 is fully completed, ensuring strict order. Now, the cascadeless schedule. In cascadeless schedule, if a transaction is going to perform read operation on a value, it has to wait until the transaction who is performing write on that value commits. For example, let's say we have two transactions TA and TB. TB is going to read the value X after the W of X of TA. Then WB has to wait for the commit operation of transaction TA before it reads the X. Now, what is recoverable schedule? If a transaction reading a value which has been updated by some other transaction, then this transaction can commit only after the commit of other transaction which is updating value. So example, here TB is performing read operation on X after the TA has made changes in X using the write of X command. So TB can only commit after the commit operation of TA. So now what is serializability in DBMS? So when multiple transactions are running at the same time, there's a chance that database could become inconsistent, right? Obviously. So it is a method to check if a set schedule, a sequence of transactions ensure the database remain consistent or not. So what is a serializable schedule? This is a schedule that always keeps the database in a consistent state, regardless of how transactions are arranged. So what is a serial schedule now? In a serial schedule, transactions are executed one after the other. The transaction starts only when the previous one finishes. Just we have discussed now. And what is non-serial schedule? We have discussed. Now, what is conflict serializability? In conflict serializability, it is one of the type of serializability which can be used to check whether a non-serial schedule is conflict serializable or not. Now, what is conflicting operations? The operations are called conflicting operations if all the following three conditions are satisfied. Both the operation belongs to separate transaction, both works on the same data item, at least one of them contain one write operation. So note, conflict pair for the same data items are read, write, and write, read. So we will see now how precedent graph is made for serializability in DBMS for a particular schedule. So this is the schedule. For this schedule, how we will draw the graph. So first of all, at time T1 in transaction T1, here basically read X is being performed and there is no conflict in both the transaction T2 and T3. Similarly, now talking about read Y operation in transaction T3, here also there is no conflict operations. But now when we talk about the read X operation in transaction T3, there is a conflict which is write X in transaction T1. So we cannot, and we know that read and write is a conflict pair. So here conflict arises. So what we will do here, we will draw basically a edge from T3 to T1. So this is was the earlier graph. Then we are drawing the edge from T3 to T1. Similarly, by following the same concept, we will complete the entire graph and the graph will look like this. Now, after all the steps, the precedent graph will be ready and it does not contain any cycle or loop. Obviously, it does not have any cycle or loop, right? So the above schedule S2 is conflict serializable and it is equivalent to a serial schedule. Above schedule S2 is transformed into the serial schedule by using the following steps. Now we check the vertex in the precedent graph where in degree is equal to 0. So take the vertex T2 from the graph and remove it from the graph. So obviously T2 has in degree is equal to 0 because no arrow is pointing towards it. So we are just removing T2. Again check the vertex in the left precedent graph where in degree is equal to 0. So take the vertex T3 from graph and remove it from the graph and draw the edge from T2 to T3. Obviously, T3 also do not have in degrees equal to 0. So we are also extracting it. Now we are drawing the edge from T2 to T3, and the remaining T1 is also drawn, and the edge from T3 to T1 is drawn. So now this is equivalent to schedule S2. So this was the earlier schedule, and this is the converted serial schedule. Okay. Now, what is serializability? It is a type of serializability that can be used to check whether the given schedule is view serializable or not. So now what is view equivalent? Two schedules S1 and S2 are said to be view equivalent if both satisfy the following conditions. Initial read and initial read of the data item in both the schedule must be same. For example, let's do schedule S1 and S2. If transaction T1 reads the data item A in the schedule S1, then in schedule S2 transaction T1 also reads A. Okay. So consider an example, above two schedules S1 and S2 are view equivalent because initial read instruction in S1 is done by T1 transaction, and in schedule S2 is also done by transaction T2. So both are performing the read operation. Now, what is concurrency control protocol? So basically, concurrency control in database management system is a procedure of managing simultaneous operations without conflicting with each other. So now, so just we have discussed the problem. So these two statements, okay, are discussed. Now talking about concurrency control protocol. Concurrency control protocols are essential for managing simultaneous access to shared data in a database management system. These protocols ensure data consistency and prevent conflicts between transactions. So we have learned about the three conflicts, which are read write, then we have write read, and then we have write write. Now, what are these protocols? First is log-based protocols. So these are the mechanism in which a transaction cannot read or write the data until it acquires an appropriate log. Log-based protocol help to eliminate the concurrency problem in DBMS for simultaneous transaction by locking or isolating a particular transaction to a single user. So binary logs. A lock is a data variable which is associated with a data item. This lock signifies that operations that can be performed on a data item. A binary lock on a data item can either locked or unlock states. Second is the shared lock method. So basically, it is also called as a read-only lock. With the shared lock, the data item can be shared between transactions. This is because you will never have permission to update data on the data item. Example, consider two transactions reading the account balance of a person. The database will let them read by placing a shared lock. However, if another transaction wants to update that account's balance, shared lock prevented until the reading process is over. Now, what is the exclusive lock? X. So with the exclusive lock, a data item can be read as well as written. This is exclusive and can't be held concurrently on the same data item. X lock is requested using lock X instruction. Example, when a transaction needs to update the account balance of a person, you can allow this transaction by placing X lock on it. Therefore, when the second transaction wants to read or write, exclusive lock prevents this operation. Now, two-phase locking protocol. So basically, it is also known as 2PL protocol. So it is a method of concurrency control in DBMS that ensures serializability by applying a lock to transaction data, which blocks other transactions to access the same data simultaneously. So there are phases in this method. So these are growing phase and shrinking phase. So basically, the second part is where the transaction obtains all the locks. When a transaction releases its first lock, the third phase starts. So basically, before that, in the first phase, when the transaction begins to execute, it requires permission for the lock it needs, and then the growing phase is started. Now, talking about shrinking phase, so in this third phase, the transaction cannot demand any new locks. Instead, it only releases the acquired locks. Now, what is a time-based protocols? So basically in DBMS, it is an algorithm which uses the system time or logical counter as a timestamp to serialize the execution of concurrent transactions. So priority. The older transaction is always given priority in this method. It uses system time to determine the timestamp of the transaction. Suppose there are three transactions T1, T2, T3. And suppose T1 has entered at the time 0010, T2 at 0020, and T3 at 0030. As T1 has entered earlier, so it will be given the priority first. Now, validation based protocol. So in DBMS, it is also known as optimistic currency control technique. So it is a method to avoid concurrency in transactions. In this protocol, the local copies of transaction data are updated rather than the data itself. which results in less interference while execution of the transaction. So here also three phases are there. Read phase, data values from database can be read by a transaction, but the right operation or update are only applied to the local data copies, not the actual database. Validation phase, the data is checked to ensure that there is no violation of serializability while applying the transaction updates to the database. Write phase, the updates are applied to the database if the validation is successful, else the updates are not applied and the transaction is rolled back. Now, recovery techniques. So, database systems like any other computer system are subject to failures, but the data stored in them must be available, and when required, when a database fails, it must possess the facility for fast recovery. It must also have atomicity, that is, just we have discussed. Okay. Now, there are three techniques. System lock, the technique used to recover the lost data due to system crashes, transaction errors, viruses, etc. These recovery techniques are heavily dependent upon the existence of a special file known as system log entries. It contains information about the start and end of each transaction and any update which occur during the transaction. The log keeps track of all the transaction operations that affect the value of database items. A checkpoint. So it is a mechanism where all the previous logs are removed from the system and stored permanently in a storage disk. Checkpoints declare a point before which the DBMS was in consistent state and all the transactions were committed. So thank you everyone for listening.